uh, daily challenges jump game. Question number 55, LeetCode. We are given with an array and we are standing at the index I is equals to 0. We need to check if we can reach the end of array, the last element of the tool. We need to check if we can reach the last element in the array. So let's do it. So according to question, we are standing at the 0th index, and at for each index the value denotes how much distance we can go forward from that index. So if I am standing at 2, if I am standing at 0th index, the value is 2, means I can go till this, but I can also stop in between. So I can travel to 3 or 1. Similarly, for if I'm standing at 3, I can travel to this one, and this value 4. If I am standing at I is equals to 0, 1, 2, 2, I can only go one move forward. For this also one move forward. At 4, as it is end of array, the last element of array, we can't go forward, and this is the final destination for us. So we need to check if we can reach the end of the array or not. So the brute force way is to obviously go with recursion and check for each possibility. So how will we approach it is very simple. So we are first of all at I is equals to 0. So we are at I is equals to 0, and a of I is equals to 2, which means that we can go to I is equals to 1, or we can go to I is equals to 2. Now if we go to I is equals to 1, the value is 3, so we have 3 possibilities. So we can go to I is equals to 2, I is equals to 3, or I is equals to 4 directly. For I is equals to 2, we have only one possibility, to go to I is equals to 3, and for I is equals to 3 also we have one possibility, to go to I is equals to 4. Here exact same tree, I is equals to 2 to I is equals to 3, and then I is equals to 4, I is equals to 4, and when we reach I is equals to 4, it's our final destination. We will stop there and return true. Now as we drawn this recursion tree only, we can see that we are doing several calculations, we are doing same calculations several times. So for example, when we will be solving this, when we are computing this, we can see that we already have solved I is equals to 2, and we will be solving again it in future. We have solved I is equals to 3, we will be solving it in future. So what we can do is we can right away optimize it by storing the results. So that is basic memoization to avoid recursive calls. We can also go ahead and further tabulate it to further reduce the space complexity of recursive call stack. Now again, after even using the DP, our time complexity will be polynomial, and not sure about it being big of n only. It can go quadratic, biquadratic, cubic, any polynomial. So recursion as well as DP, both of them won't give us optimal solution. We have another way of doing it, that is greedy. Now we can wonder why greedy is going to work here, but it will Let's see how. So we have this array 2 3 1 1 and 4. So now what we can do is simply keep track of at most which index we can go. So first of all, we are at I is equals to 0. As soon as we see that a of I, so a of 0 is 2, we can update that max I we can go is 2. Now we move forward, we have 3. So now this is I is equals to 1 itself only. So max I which we can reach is, max I is now I is 1 itself, and a of I, so a of 1, that is 3. So maximum index which we can reach now is 3, which we can reach now is 4. So 0 1 2 3 and 4, fourth index. So as soon as we got max underscore I is equals to 4, that is size of array, last index of array, we can return true. Now to just take one more example to dry run, we can take 3 2 1 0 4. We will keep track of max underscore I. At first index we will have index plus value at that index, so 3. So we can reach at max third index. Now we go to second index C. Our max I will be 1 plus 2 here. It will be again 3, so it's same value, does not matter. We go further, we have 1. So now max underscore I is equals to 0 into second index, and the value is 1. Again we got 3. So now we will reach third index, max underscore I is equals to its index, that is 3, and value 3. Now what we can see is our max underscore I is not increasing even after scanning till max I itself, which means that it is the last index at which we can reach. Hence we can say that we will return false. Let us see code for the same. So here first of all we can eliminate one edge case. Let us just make a function. Firstly, helper function and a vector of integers, nums array, nums vector. So our first edge case will be when we encounter array of size 1. So we can say that we are already at end of array, so no need to check further. We need to keep track of at which element we currently are at and how much far we can go, so at which final index we can go at max. So we'll declare two variables. First one is current position, that is just initialize it with the 0, and another variable int max I, and max I initially will be the nums of 0, so till that index we can reach. Now we start scanning through the array, traversing through the array, whatever we want to call it, while current is less than or equal to max I. So it means that we are still not reached max I. Till that we are going to traverse, and each time we will try to update max I, current plus nums of current. So what this will do is it will try to update the value of maxi each time. So our current index and how far can we go is denoted by current index value. So we try to update it and we check if at any time our maxi is greater than or equal to last index of array, that is nums dot size -1. We will return true, that it's possible. Otherwise, each time we need to traverse the array. If after traversing the array we still didn't reach end of the array, we can simply return false. So this was the greedy solution, which will take big O of n time, and space complexity will be big O of 1, as we are not declaring any storage, as we are not using any memory which are other than any variables, or which are not proportional to provided input.